Welcome guys, we're on lesson 9-3, so we're still working on fractions, and today we're working on adding fractions with using what's called our standard algorithm. So basically that just means how do we add fractions the normal way. We're not going to draw models this time, we're not going to use fraction strips, we're really just going to look at, well, if the denominators are the same, then you add the numerators. So that's all we're going to be doing. We're also going to be talking about how we change this from a fraction, this is called an improper fraction. And why is it improper? Well, it's because the numerator is greater than the denominator. So if that top number is bigger than the denominator, then what we do is we write it as a mixed number. And think of it as baking. Mixed means you take two things and you put them together. So here we have two things. We have a whole number and a fraction. That's why they're mixed. There's two different things. And how we do that is we see, well, there is, since that top number is bigger, we can take out one whole, which is 5/5. And then how do we get to 7/5? Well, we'd have to add 2/5. So we're taking out a whole from an improper fraction. And then we're seeing what fraction part is left over. So this is how they got 1 and 2/5. They took out one whole, and then they had 2/5 left over. So, number one, using the survey on the previous page, what fraction of the club members chose either a bird or a cat? Well, we don't have the survey with us because it was on that previous page, but a cat, if you remember, was 5/12, and a bird was only 1/12. So, which one they chose either one of those? Well, that means we'd add them together, so we'd get 6/12, which is also the same as 1/2. Let's head down to number 2 now. Greg found 1/3 plus 2/3 equals 3/6. What error did Greg make? Well, right away I noticed it's wrong because remember, when we add, the denominators need to stay the same. And here he changed the denominator, so I believe that's the mistake he made. So Greg added the denominators instead of using like, or you may hear it called common or same denominators. So let's head on to number 3 now. 2/4 plus 1/4, the denominators are the same, so we just add our numerators. 2 plus 1 is 3, and the denominator stays the same. Here, denominator stays the same, so we just add those numerators. So 1 plus 2 is 3, and this is equal to 1 whole. Down here, we have the same denominators, so the denominator will stay the same, and we have 2 plus 11, which is 13. Notice the numerator, the top number, is bigger than the bottom number. So that means I'm going to take a whole out and write as a mixed number. So I'm going to take 12/12 out because remember that's a whole, and then I'd be left with 1/12 left over. So that's going to be what? It's going to be 1 whole with 1/12 left over. Number 6, we have 5/10 because those denominators are the same. Down here, denominators are the same, so it's going to be an 8. 2 plus 1 is 3. Number 8, we have 2 plus 3 is 5/6. And over here, the denominators are the same, so we can add just the numerators. 1 plus 4 is 5. Number 10, denominators are the same, so we can add them. 2 plus 3 is 5 as well. Number 11, 3 plus 5 is 8, and remember those denominators stay the same. Over here, 5 plus 4 is 9, and the denominators stay the same. This one's just a little bit different because there's 3 fractions, but it can be the exact same thing. So, denominator stays the same, and then we add those numerators. 4 plus 3 is 7, plus 2 is 9. So notice here, I have a numerator that's bigger than my denominator, so I need to take out a whole. So that's 5/5, and I'm left with 4/5. So what does that equal? Well, that equals 1 whole and 4/5. Remember, we do not want to leave them as an improper fraction. Remember, an improper fraction is when that numerator, when the top number is bigger than the bottom number. Okay, over here, denominator stays the same, so we add 3 plus 2 is 5, plus 6 is 11. Again, we have a numerator that's bigger than the denominator, so we're going to take out a whole. Remember, a whole is 10 tenths. I'm left with 1/10. So now what does that convert to? Well, that's going to convert to 1 whole with 1/10 left over. Number 5, we have 2 plus 5 is 7 over 6. And then that numerator is bigger than the denominator, so I'm going to take a whole out, which is 6/6, and I'm left with 1/6, because 1 plus 6 equals 7. So now I'm left with 1 whole and 1/6. Down here, we have 3 plus 9 is 12 over 6. So what do? Well, that numerator is bigger than the denominator, so I need to take out my wholes. So I'm going to have 6/6, and then what do I have left? I have another 6/6 left. So look at that. That is 2 wholes. 1 whole, 2 wholes. So we can take out more than 1 whole if it lets us. Okay, denominators are the same. 11 plus 11 is 22. So what do I see here? Well, I see I have 1 whole, then I'd have another whole, and then I'd have 2/10 left. Notice again, when we're breaking them apart to take those wholes out, the numerator should equal our numerator that we started with. So what do I have? Well, I have 2 wholes, 1 whole, 2 wholes, and then I have 2/10 left over. So my final answer is 2 and 2/10. This one, 1 plus 7 is, not 9, is 8 over 8, which this equals 1 whole. So let's head to our next page. We have to be able to see our chart. So using this table, what fraction of the set is either triangles or rectangles? Well, triangles I see as 2/10, and rectangles I see as 4/10. So what fraction is one of those? Well, we add those together because we have 2 shapes and 4 shapes, which gives us 6 shapes out of 10. Which 2 shapes make up 7/10 in the set? So we need to figure out what plus what equals 7. So let's see. 2 plus 4 doesn't equal 7. 2 plus 1 doesn't equal 7. 2 plus 3 doesn't equal 7. 4 plus 3, that equals 7. So that's 4/10 plus 3/10 equals 7/10. And what shapes were those? Well, I see it is my rectangle and it is my circle. Which 2 shapes make up half of the set? So remember, half is going to be 5/10. So what 2 shapes add up to equal 5/10? And that says 2 possible answers. Well, we have a rectangle and we have a what's called a 6-sided shape is a hexagon. So we have a rectangle and hexagon. And if you think you're done though, you're not, because remember it says 2 and we've only found 1. So it's probably going to be the other 2 shapes. So that would be a triangle and a circle. (22) There are 64 crayons in each box. The school bought 25 boxes of crayons for art class. The crayons are shared equally among 5 classes. How many crayons will each class get? So what do you think we need to do? Well, first, we need to figure out the total. So we could draw a tape diagram. There'd be 25 boxes. That'd be 1, 2, 3, 4, 5, all the way up to what? To 25. And then each box would have 64. Which, when I see that, that's repeated addition. We're adding the same number over and over and over, which means we can multiply. So we need to multiply what? 64 times 25. So I'm going to zoom on in. 5 times 4 is 20. Regroup the 2. 5 times 6 is 30, plus 2 is 32. Then I'm going to my next place value, so I add that 0. 2 times 4 is 8. 2 times 6 is 12. And then we just add them up. 0, 0, regroup the 1, 6. So there's a total of 1,600 crayons. But wait, that's not all, because remember it says we're sharing them equally. So we have to divide them between 5 classes. So let's zoom on in. Remember our steps. We have, does McDonald's sell cheeseburgers? So 5 goes into 16 3 times. Multiply 3 times 5 is 15. Subtract, and I get 1. 1 is less than 5, so I'm good to keep going. So I bring down. 5 goes into 10. How many times? It goes in 2 times. Oops, I did not check as I did it. It goes in 2 times. I multiply. 2 times 5 is 10. I subtract, and I get 0. 0 is less than 5, so I checked. Then I bring down a 0 again. 5 goes into 0 0 times. 0 times 5 is 0. Subtract, and I get 0. 0 for my check is less than 5. There's nothing to bring down, so this is my answer. So how many crayons does each school get, or each class get? Each class gets 320 crayons. 23, 3/10. So I'm going to just write it as 3/10, so I know it's that number, are blue. So I'm going to put 3/10 are blue. 4/10 are green. And what's nice about doing all iPads, I can color code these. And the rest are black. What fraction of the buttons are black? Well, it's telling us there's this mystery number, and it needs to equal 10/10. Why is it 10/10? Well, remember, when we use a fraction, that denominator tells us how many total pieces we need to make a whole. So to make a whole is 10, because that's our denominator. So what mystery number is this? Well, we have 7/10 plus a mystery number equals 10/10. So our mystery number has to be 3, because 7 plus 3 equals 10. So 3/10 are black. Now 24. Draw lines connecting each fraction or mixed number on the left with the correct expression on the right. So we need to figure out which one of these equals 3/4. Well, the easy thing first is the denominator should equal 4. So let's check that out first. And I see it right here. 2 plus 1 equals 3. So there's our first one. Our next one I see right here is 8. So I should look for a fraction that has 8 in its answer. And I see it over here, so let's just add, just make sure. That's 3 plus 2 is 5. 5 plus 32 is 37. But I have this issue. Is 37 equal to what? 4 and 5/5. So let's pull those holes out. So 8/8 plus 8/8 plus 8/8 plus 8/8. That's 32 eighths. And so that means there's 4 holes there. And we'd have 5/8 left over. So yeah, oops. It does look like this one matches. Our next one, we need to have 6. Notice though, there's 2 with 6s in them. So let's figure this out. This would be 6, 6, which that's a hole. So it's this one down here. Now just to make sure, this would be 7, 6, because 6 plus 1 is 7. So there's our answers. Okay, now we're going to do the same thing for this one. There we go. So let's start with the tenths. And I see right here, it matches here because 1 plus 1 whole equals 1/10. And how do I know it's 1 whole? Well, this is 1 whole, and this is 1/10. And this is just 0, so it's like it's not even there. Okay, our next one. There's no holes here, so let's go to our 12th and see if we can match this one up first. So I look over here, I think it's this one, but let's just check. 3 plus 3 is 6, which is what I have over for my numerator. Now our last one we see is fourths, but both of these have fourths, so we're out of luck. Our strategy of just checking the numerators first, or the denominators, and then see if they match has run out. So let's add them up and see what we get. So this one right here, I would get 1 plus 2 is 3, plus 8 is 11/4. And down here, we would get 5 plus 3 is 8 over 4. I'm going to do this one down here because it's a shorter, or it's a smaller numerator. So it's easier to pull those holes out. So I'm going to pull out 4/4 because that's a hole. And then what do I have left? Well, I have another 4/4 because 8 minus 4 is 4. So that is 1 hole plus 1 hole. So I have 2 holes here. And look, that does match one of our answers, which means this last one goes with this top, but let's just check it. So I have 11/4, so I need to pull out some holes. So that is 4/4 plus 4/4 And then what do I have left? Well, I've taken 8 out and I start with 11, so I only have 3/4 left. So now I have 1 hole, 2 holes, so I have 2 holes and 3/4 left over. So let's see, is that what our matching pair was supposed to be? Yes, it was. So that is how you add fractions and change them from improper to mixed numbers.